Do you know if you apply some force on an object, with what acceleration it will move? Or if you have to give some definite acceleration to an object, how much force is required? This will be clear from Newton's second law of motion. Before we come to the concept of Newton's second law of motion, it's important to know the concept of momentum. To understand the term momentum, let's review some common observations. If a bicycle is moving with the speed of 40 meters per second and hits a person on the road, the person will fall and may get some injuries. But on the other hand, if a heavy loaded truck moving with same speed of 40 meters per second hits the same person, the person may die. This is because of heavy mass of truck. Now let's take the case of small bullet fired from the gun. A bullet fired from the gun may kill the person. Here the reason is not mass, but the velocity of a bullet with which it hits the person. Combining the two cases, we observe that the impact of motion produced by an object on other object depends on its mass and velocity. So there must be some important quantity that combines mass and velocity of an object. Newton identified this quantity as moment and defined momentum of body as a product of mass and velocity. Mathematically, we can write this. As we know, the SI unit of mass is kilogram and the SI unit of velocity is meter per second. Therefore, SI unit of momentum is kilogram times meter per second. So, momentum is the product of mass and velocity. Now, coming back to the earlier example of bicycle and heavy truck, let the mass of bicycle is 10 kilograms and is moving with the velocity of 40 meters per second. The momentum of the bicycle will be 400 kilograms meter per second. Let the mass of a truck is 10,000 kilograms and is moving with the velocity of 40 meters per second. The momentum of the truck will be 4 lakh kilogram meter per second. So we find momentum is larger in second case. It's clear the death of a person is due to larger momentum. If we take a case of stationary truck whose mass is 10,000 kilograms, the velocity of a truck is 0 meter per second. The momentum will be 0 as this. So we find the momentum of a rest body is 0. On conclusion, we can say momentum is related to motion of an object. Now coming to the Newton's second law of motion. It states that the rate of change of momentum of a body is directly proportional to the external net force applied. The change is in the direction of applied force. Let's try to understand it in more clear way. Let the initial momentum of body is equal to mu, where u is the initial velocity, And the final momentum of body is equal to mv, where v is the final velocity. Change in momentum will be mu minus mv. Since rate of change of momentum is change in momentum per unit time, so rate of change of momentum is this. But we know change in velocity per unit time is acceleration. That is, acceleration is this. Thus, rate of change of momentum depends directly on mass times acceleration. But according to the statement of Newton's second law of motion, rate of change of momentum is directly proportional to the net force applied. Thus, we can say force is directly proportional to mass times acceleration. To remove the sign of proportionality, we put a constant k. So we can write F is equal to k times mass and acceleration. The value of k depends on units adopted for measuring force, and it comes out to be 1. So putting the value of k in above equation, we have the final equation of Newton's second law of motion as this. With this equation, we can find the SI unit of force. As the SI unit of mass is kilogram and that of acceleration is meter per second square, so the SI unit of force is kilogram times meter per second square. And this is what we call as Newton. We can find 1 Newton as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second square. Let us try to understand Newton's second law of motion in more simpler way. If we apply some net force on an object kept on the ground, obviously there will be some acceleration in that object. Now the question is on which factors the acceleration will depend. If we first apply a force of 10 Newton, what will be the acceleration? Now if we apply a force of 20 Newton, in which case the acceleration will be more. Obviously it will be the second case. So we can say one of the factors on which acceleration depends is applied net force. More the applied force, more is acceleration. Or we can say this. Now let there are two objects on the ground, one with lesser mass and one with greater mass. And you apply a force of 10 Newton on each. Surely the object with lesser mass will move with larger acceleration than the object with larger mass. This is because of lesser mass of an object. So we can say the other factor on which the acceleration depends is mass of an object. Lesser the mass, more is the acceleration. In other words, acceleration depends inversely on mass of object. On combining the two cases, we can say Acceleration depends directly on applied net force and inversely on mass of an object. Mathematically, it can be written as this, or in simple terms, F is equal to mass times acceleration. This is all about Newton's second law of motion.